Hi guys, in this tutorial we're going to look at some more examples on projectile motion. So look at the first question here. So here the question says that we have a dart that is thrown horizontally with an initial speed of 10 meters per second towards a point P. The bullseye on the dartboard, towards a point B, the bullseye on the dartboard. Okay, so we continue. So it hits a point Q on the rim vertically below point P 0.19 seconds later. Then the question is asking us to find what the distance PQ is. So the first thing that we have to do here is to have a clear picture of what is actually happening here. So if we look at where the dartboard is, so let's picture this to be our dartboard. So of course, let's say the bullseye is somewhere here, right on the middle of this circle, and this is where the point, where the point on the bullseye is. So this point is labeled as the point P. So this is where our point P is. So our dart is being thrown to hit that spot. And what happens? So they're saying that it hits a point Q on the rim vertically below P. So they're saying that this dart that we are throwing at this point, it doesn't hit the point P. Instead, it ends up hitting a point Q that is somewhere on the rim of this dartboard. So this is where that point, that's point Q. So the point Q is. Now the question is, what is the distance PQ, the distance from P to Q? Now that we have a visual image of what is happening in terms of the dart, what about in terms of the motion of this dart? So picture it that the dart is being thrown from this particular point. So let's view it as something like this. So of course it's aimed at the point P. So let's say point P is along this horizontal line somewhere here. So this is where the aim is. That's where the aim is at. So let me try to draw it better. So something like this. Okay, so I hope this doesn't look too good. Let's try to make it a little bit better. Okay, that will have to do. So this is where our point P is. So the dart is being thrown to go or to hit our point P. But does it hit our point P? No, it doesn't. Instead, it hits a point that is vertically below point P. So it hits a point Q that is somewhere here. Now the question is, what is the distance between P and Q? The question is telling us that Q is right below P. So vertically below P, that's where Q is. So the idea here is that the dart follows some projectile path because it will be affected by gravity in the vertical axis. So when you throw it, the dart follows a path that goes more like this until when it hits that point Q. So that is the trajectory the dart is going to follow. So again, I hope you remember the trajectory is just a path that a projectile follows. So once we have this clear image of what is actually happening, the question is asking us to find what this distance here is. So we can label this distance as the height edge. Now, of course, we know to say when dealing with projectiles, we always approach them in the respective axis. So we'll approach it first in the y-axis to determine or evaluate what is happening in the y-axis. Of course, the key relationship between the y-axis and the x-axis is the time. The time it takes to move vertically from this level up to the level where point Q is. Point Q is at this level. So it's like the time it takes to move following this trajectory until it hits Q, it will be the same time it will take with the y component only, but now to move vertically downwards until when it reaches that level. Notice that now I'm saying that the time it took to hit point Q will be the same time it takes to just move from that height, which is the same level as P, to the same level as Q, but with the initial velocity as the y component it had when it started moving. So with that in mind, when the dart was thrown, look at what the question is saying. It is thrown in a horizontal manner. What this is telling us is that even though the dart was given an initial velocity when we were throwing it, that velocity was horizontal, and that velocity was 10 meters per second. It did not have a vertical velocity. Because of that, the initial velocity in the y-axis is going to be 0. So, but in the x-axis, of course, we know to say it's going to be that 10 meters per second it was thrown with. So the initial in the x will be 10 meters per second. What else is the question telling us? Okay, so the next part is somewhere here. It hits a point Q on the rim vertically below P 0.19 seconds later. So the time it takes to move in the y-axis up to the level where Q is the same as the time it will take to cover that horizontal distance from the launch point from here all the way up to this level. So those two times will be the same, and they will be the same as the total time it took to just hit point Q. And the question is telling us it took 0.19 seconds to hit point Q. So 0.19 seconds, that's the same time it will take in the horizontal axis. Okay, now what else are they saying? Okay, 0.19 seconds later. What is the distance PQ? So let's find the distance PQ from P coming down up to Q. Notice that that is a vertical distance, so I will be dealing with the y-axis. So in the y-axis, my initial is given us that my time is this. I'm looking for my displacement labeled as just the height h. And then we know in the x-axis, gravity is present. So I'll take gravity to be negative 9.8 meters per second squared. So if I was to lay down my equations of motion, v is equals to u plus at, we know in the vertical axis, the presence of acceleration implies that we have to use one of these equations. I always resort to these, so I'll just put them down here. Then we have u squared plus 2as. I look at what I'm given. I start with what I'm looking for. I'm looking for h here, for the displacement. So only this equation and this equation have the displacement. So I'll use one of these. And then next, I want to see which one will be easiest to use here. Now look at this. I want an equation which has everything except the thing I'm looking for. Unless maybe I don't have such. That's when I'll start looking for other ways. In this case, I see I don't have the final velocity. So I'll avoid an equation that has final velocity, unless if it's easy to find the final velocity. In this case, that results into that equation. So my displacement will be equals to ut plus half at squared. So my displacement, I labeled it as h, will be equals to the initial velocity in the vertical axis, that's a 0, multiplying the time 0.19, that was 19, yes. And then plus half the acceleration minus 9.8, and then t squared again 0.19 squared. And then from here, we work out this expression for h, and we get negative 0.176 17689. This is in meters. The negative here just implies that it's a downward displacement, but since the question is just looking for the distance between the 2 points, we can just say therefore the distance will be equal to 0.177 meters, or we can give this in centimeters and say this is 17.7 centimeters below. So that's the distance between the 2 points P and Q. In the second part, the question is asking us how far away the dartboard is. How far away the dartboard is from the dart how far away the dartboard is from the point where the dart is being released. So here, the dart is being released from this point. Let me label this point as point A. Now, how far away is the dartboard? Well, the dartboard is right here at point P, or at the same position as P. So I can say this is our dartboard somewhere here. So how far away is the dartboard from that point? So let's say this is our dartboard here. Now, how far away is the dartboard from where the dart is being released? In other words, we're looking for the horizontal distance between point A and point P. So to find the horizontal distance, see that we're now in the horizontal axis. And in the horizontal axis, you have to remember that there is no velocity, there's no acceleration there. The only acceleration that affects a projectile is going to be that due to gravity. Of course, this implies that we are assuming that there is no air resistance and so on. So this implies that we are in the x-axis. And in the x-axis, the dart was thrown with a horizontal velocity of 10 meters per second. And we're looking for the distance it covers, the horizontal distance. So let's just call that d to mean the horizontal distance. Now, the next thing that we want to look at here is the time. How long did it take to cover that horizontal distance? Well, we already pointed out earlier on that it took the same time as it did in the vertical axis. So because of the absence of acceleration here, we use the formula for speed. Speed is equals to distance over time. Since we're looking for the horizontal distance d, we'll just say the speed, which is 10, multiplying the total time, which is 0.19. And if we get the product here, we get 1.9 meters. So this is how far away the dartboard is from the point where the dart was released. So this was the second part of this question. And now we can move on to the second question. And what is it saying? A small ball rolls horizontally off the edge of a tabletop that is 1.2 meters high. It strikes the floor at a point 1.5 meters horizontally from the table edge. Now they want us to find how long is the table in the air, how long is the ball in the air, sorry for that. And the second part, what is the speed at the instant it leaves the table? Okay, let's first create a picture of what is happening there. So it's very important for us to understand what the question is saying. And if we mess up the picture or the image of what is happening, then we'll get the question wrong. So let's say this is the floor. And then our table is, let's say, something like this. I'll just draw the edge. So let's assume this is the setup that we have. So we have our table here in blue, and then we have our ball there in red. Now, what is happening here? Well, let's go back to the question and get everything else. Well, they're saying a small ball. So the ball is very, very small. So that its diameter is very, very small compared to the height of the table. That will be very important for our assumption. So a small ball rolls horizontally. So the table is flat out horizontal. And then off the edge of a table that is 1.2 meters high. So that part implies that the height of the table is 1.2 meters. So again, this height is approximated to be from the ground all the way up to the edge where the ball is leaving the table. So right up to here, this height is 1.2 meters. So let me write it somewhere more visible. That is 1.2 meters. So that is h. Okay, the next thing that we want to see is, let's see what they're telling us here. So yeah, 1.2 meters high. It strikes the floor at a point 1.52 meters horizontally from the table edge. So the table edge is right here. So it strikes the floor. So let's say this is where the table edge is. So it strikes the floor. Let me use a different color for that. So let's say the projectile or this ball follows a path. So again, we're assuming this is very, very small, such that we can use only the height of the table without considering the diameter of that ball. That's why the question even reads a small ball. In most of these calculations, this is the assumption that we'll be making. So we'll assume this is the trajectory that this ball follows until when it lands. And then when it lands, it hits the ground somewhere here. Now, what they're saying is the distance from the edge of this table up to where the ball actually lands. So this is a horizontal distance. The ball gets to land somewhere here. So this horizontal distance, according to the question, that is 1.52 meters. Okay, so that is 1.52 meters. So the horizontal distance d is 1.52 meters. So they've given us the vertical distance and also the horizontal distance. What else have they given us and what are we looking for? So in the first part, they're saying how long is the ball in the air. So how long is the ball in the air until it lands? Now, a mistake that the student might do here is perhaps to think about this as something which is a straight path, to say that the ball just gets to move like that and then use Pythagoras theorem here and there. Well, you can't do that. This is a projectile, unless if they ask for the direct distance from where the ball leaves the table to where it hits the ground. Then yes, you can use Pythagoras. But in this case, we'll just have to use the concepts we've looked at in projectile. So the question is actually asking for two things. They want us to find two things here. In the first part, they want us to find how long the ball is in the air. So they're looking for time, the total time of travel. And in the second part, they're asking us to determine the speed at the instant it leaves the table. So the initial speed that the ball actually has. So with that in mind, let's look at what we have. Let's start with in the y-axis. So in the y-axis, what are we looking at? Well, in the y-axis, we see that just like in the previous case, the ball rolls off horizontally. So it rolls off while moving with a horizontal speed. What this is telling us is that it didn't have an initial velocity in the vertical axis. It only had the velocity it rolled with, and that velocity was all in the horizontal axis. So in the y-axis, the ball had a zero velocity there, but we know it is affected by gravity. So we have that minus 9.8. Then the other thing we want to keep in mind here is that it falls off. The height here is h, and h is given as 1.2. So the height it falls through, we'll take this as negative 1.2 meters. Now here you have to just keep in mind, if you take your acceleration as positive going down, then you will have to take your displacement going down also as positive. Otherwise you get this wrong. Okay. So here I'm taking acceleration down to be negative, so I'm taking my displacement to also be negative. The next thing we have in the y-axis is we know to say the time it would take to fall in the y-axis until it hits the ground 1.2 meters below, t, this time will be the same as the time it would take to move in the horizontal axis, cover that 1.52 meters. So let's see what we actually have in the x-axis. So in the x-axis, what we see is that it actually starts with that initial velocity, which we also don't know u. But the acceleration here is 0. It covers a distance d equals to 1.52 meters, horizontally. Then it takes some total time t that we also do not know. You notice that here we have this unknown, and here we have two unknowns, this and this. So in most cases, or in some cases, you would have to, especially when the initial velocity also applies in the y-axis, you'd have two unknowns, the initial velocity here and time, even here initial velocity and time. You'd have to solve a simultaneous equation to get the answer. But here, because the initial velocity is 0, it implies that we can actually get the time from the y-axis. So since we're looking for the time here, again, we don't have the final velocity. So when you write down the equations, you see that the equation that will work for you is going to be s is equals to ut plus half at squared. But because the initial velocity is 0, this term here becomes a 0. Then our displacement is downwards 1.2 negative. And then we have half of minus 9.8. And then we have t squared, the total time. This becomes minus 1.2 equals to minus 4.9, then t squared. So the negative falls off, divide both sides by the coefficient of the t squared. We get t squared is equals to 1.2 over 4.9. Then square root, we get t is equals to the square root of 1.2 over 4.9. And the answer comes out as 0.49487 seconds. Or we can write this as 0.495 seconds. So, but in the next calculation, I'll use the full value instead of the rounded off value. But you might also use that, you will get some marks there. Okay, so we have found how long the ball was in the air, which was the first part. Yeah, which was the first part. How long was the ball in the air? In the second part, they are saying what is the speed at which at the instant it leaves the table. Because we're looking for the speed there, of course, we see to say that in our information, the speed is only present in the initial velocity. The time it takes to fall down, we've seen that this is 0.495. So that will be the same time here as well. So we now go in the x-axis, in the x-axis with the information that we saw earlier on, and the absence of acceleration there again implies that we're using speed is equals to distance over time. The speed is what we are looking for, the initial one. The distance it moves through is 1.52 divided by the time, which is 0.495. I'll use the one I still have on my calculator to get the answer, which is 1.52 divided by my time there, which comes to give me 3.07 meters per second. So this is the velocity that the ball actually rolled off with. In this case, if we look at question 3 now, we have a case where it's similar to question 1. So most of these questions are actually very similar, and I hope you guys are able to pull it off. So here, of course, they're now saying we have a bullet. Let's say a projectile. A projectile is fired horizontally from a gun that is 45 meters above the flat ground, emerging from the gun with a speed of 250 meters per second. How long does the projectile remain in air? That's the first part. So try to see the pattern in how these questions actually go. If you're still having trouble with that, try to see my introduction. I'll put a link as well. My introduction, I think it's there on YouTube. So let's see what is actually happening here. We have the 45 meters and the 250. What are they and why are we going to use them? So this is question 3. So in this case, if you look at what is happening, we have our projectile being fired from a gun. Now, the question is telling us that this gun is some distance above the horizontal. So the distance from where the gun is up to the ground, let's call this h. This height is being given as 45 meters. Yeah, that's 45 meters. And the gun is being fired, or the bullet is being fired horizontally with an initial velocity of 250 meters per second. So this is a horizontal velocity. So again, we're seeing a case where the vertical component initially is 0 because all the velocity was horizontal. So what we expect is that this being a projectile, it will be affected by gravity. So just like the other cases, we expect a trajectory that will be like this. Okay, so with that in mind, the question in the first part is asking for how long the projectile was in air. That's the first part. How long does the projectile remain in the air? So just like we saw before, we don't have the final velocity. So we'll still use S is equals to UT plus half AT squared. So because in the vertical axis, if you take down the information, that's where you have the most. So we'll start with in the Y axis. So I hope you guys are able to do this on your own. The displacement is a downward 45 meters. So I'll say negative here. And then this is equals to the initial in the y-axis, that's a 0. So all this will be 0. So we only have half here, minus 9.8. And then we have the t squared here. Like before, the negative will cancel. So that we have 45 equals to 4.9. And then the t squared here. So that the t will be equals to the square root of 45 over 4.9. And if we evaluate this, we get 3.03 seconds. Okay, so this is the first part, it's done. Let's look at the next part. In the next part, the question is saying, at what horizontal distance from the firing point does it strike the ground? So just like before, we are now moving to the x-axis. So in the x-axis, what is happening there? Well, in the x-axis, it had that initial velocity, 250 meters per second. We've just seen that it takes 3.03 seconds to strike the ground. The total time in the y will be the same total time in the x. Now we're looking for the horizontal distance to where it strikes the ground. So that, like before, speed is equals to distance over time. So that distance will be equals to speed, 250 times time, 3.03. So this becomes equal. This comes to give us 757.6 meters away. So that would be the horizontal distance. It makes sense. This is a bullet. Look at that initial speed of 250. It has to go very far. Okay, so that answers the second part of the question. Let's quickly look at the third part. What is the magnitude of the vertical component of its velocity as it strikes the ground? So you really have to be very careful when you're handling a question like C here. And here they specify the vertical component of its velocity when it strikes the ground. Another way they could have phrased this question, if they wanted to find something else, they'd have said, what is the magnitude of the velocity, or the magnitude of its velocity as it strikes the ground? If it was phrased like this, without the vertical component part included, well, the question would have been very different to how we're going to approach it. We'll still do the same thing, but we'd have to continue to do another extra step. But the inclusion of vertical component just means that we're looking for the final velocity in the y-axis. So in the y-axis now, remember we've been using only the initial velocity, but now we have to consider what the velocity will be in the y-axis when this projectile strikes the ground. So in other words, all we're going to do here is, in the y-axis, the initial velocity, as we saw earlier, it's 0. The acceleration is minus 9.8. It falls through some distance of 45 meters, so minus. Now we're looking for the final velocity here. We also know the time, so if we need to use the time, we can still use it. So if you want to use the time, you can even use v is equals to u plus at squared, not at squared, just at. The initial is 0. The acceleration is minus 9.8. The time we found in the earlier on was 3.03. So I can say 3.03. And then if we do the math here, that's 9.8. Then multiply this by 3.03. You get minus 29.694 meters per second, which of course can be rounded off to just 29.7 meters per second. The negative just means down, and the question is asking for the magnitude, so implying that there's no need for that negative. So in other words, the final velocity in the y-axis, you can just write the magnitude of the velocity in the y-axis will be equals to 29.7 meters per second. This will be the magnitude. Another way you could have found it, if you wanted to avoid using the time that you calculated just in case you made a mistake, would have been to use the last equation of the 3 I wrote earlier on. That one doesn't use time. So you'd have had to get this. Your equation now would have been v squared is equals to u squared plus 2as. But your u squared is 0, that's the initial velocity. So that v is just equals to the square root of 2as. In this case, we get the square root of 2, the acceleration, minus 9.8. The height, that's minus 45. Notice that if you forget any of the negatives here, you'd have problems. But here, of course, we haven't forgotten. Remember that acceleration, negative going down, displacement, negative going down. So remember I said, if you take this to be positive, then take the other to be positive as well. So that we have 2 by 9.8 by 45, then the square root of the answer. And again, we get 29.7 meters per second. So it will be plus or minus, of course, we'll take the magnitude, so we'll just take the positive one. So this would have been the other method that would have used to get the answer here. That concludes question 3. Let's look at question 4 and call this a day. In the 1991 World Track and Field Championship in Tokyo, Mike Powell jumped 8.95 meters. So this guy jumps 8.95 meters, breaking by a full 5 centimeters the 23-year long jump record set by Bob. Assume that his speed on takeoff was 9.5 meters per second, about equal to that of the sprinter, and that G is equals to 9.8 in Tokyo. How much less was his range than the maximum possible range for a particle launched at the same speed. Okay, so here they're talking about the maximum possible range for a particle. Well, let me describe that a little bit. I made a video about that. You can look it up as well. I think it's there on YouTube. I'll also attach a link to it. So if a projectile is going to achieve the maximum range, what must be true? Well, for a particle to achieve the maximum range, it implies that the angle at which it should be projected has to be 45 degrees. So if you were to project a projectile at an angle, let's say theta, let's call this 45. If the angle is 45, the argument here is that the projectile actually covers the maximum range that it can ever achieve. If you were to launch the projectile at an angle less than 45, what you observe is that it actually lands a little bit nearer. And funny thing, if you were to exceed 45, closer to 90 degrees, the funny thing is it will also land somewhere nearer. It won't exceed that. So this is a concept that you have to understand. For you to achieve the maximum range, then, of course, with the same velocity, the same launch velocity, then it means that you must launch your projectile at 45 degrees. So with that in mind, I think we are better suited to answer the question now. One other thing perhaps that I should just add here is that it's possible for us to find two angles, or there will always be two angles. One angle less than 45, another angle greater than 45, such that if you launched your projectile at, let's say, the first angle less than 45, it lands somewhere here. If you launch it at that second sweet spot for an angle greater than 45, the two objects, or the projectile gets to land at the same point. So I did a video on that as well. You can look it up. It goes in details on what these concepts are. But in the meantime, let's describe this projectile based on what the question gives us. Okay, so let's see what they're saying. There's no need for us to look at that second or the world record itself. Let's just see what they're saying. In the 1991 World Track and Field Championship in Tokyo, Mike jumped 8.95 meters. So if he jumped, so this is, let's see, which one is this? This is, so he jumped 8.95 meters, breaking by a full 5 centimeters, the 23-year long jump. So this is long jump. So when I was reading this 8.95, in my head I was asking myself, wait, is it a vertical height or a horizontal height? But now that I'm seeing long jump here, in my mind I'm thinking this has to do with horizontal distance, because long jump is all about how far away you go. It's all about that range. So this 8.95 meters, it has to be a range. Okay, so let's see. Assume that his speed on takeoff was 9.5 meters. So assume that whose speed is this? That's the same guy. Assume that his speed on takeoff is this, and G is 9.8. How much less was Paul's range than the maximum possible range for a particle launched at the same speed? So let's start with the maximum possible range. So since he jumps with an initial velocity of 9.5? Is it 9.5? This guy jumps off with a velocity of 9.5 meters per second. Let's first find what the maximum range he could have achieved. What is the maximum range that he could have achieved? Since he jumps at this initial velocity, let's assume he jumps making an angle of 45. Since we want to see the maximum range, what it could have been. So we're taking the angle of projection here to be 45. So if that's the case, let's find the total time. So there are two ways we can work out this. I can go directly to get what the distance would be without taking the other routes. But in the second part, I can first find how long it takes for him to reach the top part, and then find how long it takes for him to reach the bottom part, so that I have the time for going up, time for coming down. add the 2 to get the total time of flight, then use the total time of flight to determine what the range will be. Another way would have been to just use s is equals to ut plus half at squared, solve the quadratic equation in the x-axis, and find what the total time will be. But let me start in the y-axis. In the y-axis, I want to find the vertical component. So in this case, the guy jumps with this velocity, and the velocity here is 9.5 meters per second. I want its components. It will have an x component. Since the launch angle is 45, this will be given by 9.5 cos 45, while the vertical component will be given by 9.5 sine 45. Here, the 45-degree angle is here. So because of that, the initial in the y-axis will be 9.5 sine 45. The acceleration here is minus 9.8. So this is what G is in Tokyo at that time. Then what else? First, we're going to the top part. Just as he is going up to the maximum height, the time here, or the velocity at the maximum height, v, will be equals to 0. What I want to find is how long it takes him to reach the maximum height. Let's label that as just t for now. So to reach the maximum height, what happens? Well, v is equals to u plus at. The final is 0. The initial is that 9.5 sine 45 plus negative 9.8, and then t. I'm looking for what t is. So in this case, let's do the math. So we get the 9.8 coming here, t equals to 9.5 sine 45. Then divide both sides by 9.8 so that we have 9.5 sine 45, then divided by 9.8 so that we have t is equals to 0.685 seconds. So this is the time for going up. But since he lands at the same level, the time for going up is the same as the time for coming down, so that the total time, in this case, total time will be equals to just double this, and we get 1.37 seconds. This is his total time. Now we can find, not his, this is the time it would have taken if he jumped at that, that right angle, that 45-degree angle. So let's find the maximum range that he could have achieved. The maximum range. The maximum range, now we are in the x-axis. And what is happening here? Well, in the x-axis, we know to say speed is equals to distance over time, so that the distance, which is the maximum range, will be equals to the speed. The speed is just the x component, which is 9.5 cos 45, as we saw earlier. Then multiplying that total time, 1.37. So when we multiply this, we get 9.21 meters. So this becomes the maximum range that he could have achieved. So let's compare now. What are they saying here? Well, the question says that in this competition, he achieved 8.95. So this is what he did. What he did. That was 8.95 meters. What he could have done, on the other hand, what he could have done, if he had jumped at 45 degrees, he could have done 9.21 meters. So the question is then asking us to say, how much less was his range than the maximum? How much less will be the difference between these two values? So I have 9.21 less what he did, which is 8.95, then we get 0.46. So how much less was his range compared to the max? Well, it was 0.46 meters less. So this is how we approach this question. Alright guys, hope you found this helpful. In the next tutorial, we're going to do more projectile before we move on to questions on forces. We'll see you guys in the next tutorial.